Welcome back for our second problem. Spider-Man goes to the top of a building 320 feet high to prevent Dr. Octopus from destroying the Earth. He knocks Dr. Octopus unconscious and throws him up in the air at 128 feet per second. Find position, velocity, and acceleration as functions of time. All right, so now notice we don't have an equation, but when you're looking at movement, right, what's that going to be? It's going to be the equation for gravity. So when you're throwing something up in the air and it's falling down, or you're just dropping it, right, we're going to have the equation for gravity. Oops. My R looks a little funky there. And that equation is going to be S of t, position, equals negative 16t squared, that's the coefficient for gravity, and then plus v naught t plus s naught. All right, so you should commit that equation to memory so that you remember how to write the equation when you've got something either being thrown up or something being dropped. All right, so now we just need to identify v naught and s naught. All right, so v naught is initial velocity. Right? So he's throwing him up in the air at 128 feet per second. Now we have to think, is it positive or negative? If he's going up in the air, it's positive. Right? So that's going to be 128 feet per second. S naught is starting height. And they're 320 feet high. So now we've got our pieces of information. We can write the equation for position. So S of t equals negative 16t squared plus 128t plus 320. All right, so now velocity is just the derivative of position. So v of t equals derivative of negative 16t squared plus 128t plus 320, using the power rule, will just be negative 32t plus 128. Right, and then acceleration is the second derivative of position. Right, so that a of t will be negative 32. Right, easy derivative there. All right, so by the way, what if we wanted to find jerk? Well, this is nice and smooth because jerk would be 0, because the derivative of negative 32 is 0. Right, so no abrupt changes here in our acceleration. So now B, how long will it take for Dr. Octopus to reach its maximum height? All right, so you're looking at, all right, so we're dealing with the position equation here. All right, and we've got a parabola. All right, so we're going to be at our maximum. It's going to be the vertex of the parabola. All right, so how long? We're just looking for the t value there. All right, so h or t. Right, usually when we think of the vertex, we think of h of k, right? That would be negative b divided by 2a. Right, so that's going to be, so b is 128, so that's going to be negative 128 divided by 2 times negative 16. All right, so that's going to be negative 128 divided by negative 32. Right, and so that is, using a calculator, four seconds. 4 seconds he'll reach his maximum. C, what is the maximum? Still dealing height, we were still dealing with position. All right, so we're just finding here S of what we got for the when, so right, S of 4. All right, so we've got for C, we have S of 4 equals negative 16 times 4 squared plus 128 times 4 plus 320, and that's going to be, so it's going to be negative 256 plus 128 times 4. Yeah, I don't know what I just did there, but somehow I got a decimal number. And then plus 320. All right, I'm going to put the calculator down. Oh, that's right. There we go. 576. It's really hard to hold the microphone and hit a calculator. So that's 576 feet is his maximum. When does Dr. Octopus hit the ground? Now, this so far has basically been algebra problems, right? Except for the velocity. There's our calculus. But here we're just looking at the position function one more time. When he hits the ground, remember the ground is going to be 0, right? So we want to know when S of t equals 0. So now we're just going to set our position function equal to 0. So 0 equals negative 16t squared plus 128t plus 320. Let's factor out the greatest common factor. So that's t squared minus 8t minus 20. Multiplies to give us negative 20, adds to give us negative 8. It's going to be negative 10 and positive 2. All right, so if we divide both sides by negative 16, 0 equals t squared minus 8t minus 20, and that factors very nicely into t minus 10 times t plus 2. You can ignore the t plus 2, right? Time is not negative. All right, so we have t equals 10 seconds. Bugs hits the ground. Or not Bugs, excuse me, Spider-Man. Or what's he throwing? Dr. Octopus hits the ground. All right, and with what velocity does Dr. Octopus hit the ground? Our last question. We're going to find v of 4, right? Oh, excuse me, v of 10. The time it takes him to hit the ground. Right? And we want to know what velocity he's hitting the ground at. Now we're expecting a negative answer, right? Because he's going down, right? He's up 320 feet in the air. He just gets thrown up for a little bit, and then he comes back down again. So we have v of 10 equals negative 32 times 10 plus 128, and that is negative 192 feet per second he is hitting the ground. All right, so we have solved another problem. Thanks for watching, and bye for now.